Hello guys, this is Pwm Object with TopTechBoy.com, and I am here with lesson number 27 on learning how to use your Raspberry Pi. Hopefully you've been with us through the first 26 lessons, or you can just sort of pick up with us here. What we did is basically in the first lessons we really learned the Linux operating system, learned how to find our way around the Raspberry Pi using the Linux terminal window as you see here. And now in the last few lessons what we've started doing is we've started working on interacting with the GPIO pins. Again, kind of thinking back to our old Arduino days, how we could do digital writes and analog writes and things like that to the input and output pins on the Arduino. Now we're learning on the Raspberry Pi how to interact with these pins. Just a reminder, if you were with us in our earlier lessons, we showed you first of all how the pins are numbered. I think that if you will go back to, I believe it was, give this just a second, it was lesson number 5 at TopTechBoy.com, and we are really going slow here. Lesson 25 on TopTechBoy.com. Wrong once. Raspberry Pi with Linux. We will go down to lesson number 25. And what you can find at lesson number 20 is you can find a pinout for the Raspberry Pi. This is for the Pi version 2. But it should be very similar for the other versions, and you can see there's two configurations. You can consider the pins physically, the physical pins, they're just numbered 1, 2, 3, 4, 5, 6, 7, 8, and so forth, or you can use a BCM numbering scheme, and those numbers would be shown over here. When you set your pellet, which numbering scheme that you're going to use. In this lesson, and in pretty much all my lessons, I like to use the physical pins because I don't even have to have this chart. I can just remember 1, 2, 3, 4. It's an easier way for me to remember. So I usually do things with the physical pins, okay? If you were with us in lesson number 26, what we did in that lesson is we learned how to output to the pins, and basically we were just doing simple digital outputs where we could either write the pin high or write the pin low, and so we could turn the LED on or turn the LED off. If you remember, in the Arduino days we could get sort of a simulated analog output on those digital pins by doing pulse width modulation, where you sort of simulate an analog output by switching a pin high and low and just controlling the duty cycle. And the longer it is high, the more it is like the large voltage, the smaller the time it's high, the more it is like the small voltage, and kind of the average signal coming out kind of simulates an analog signal. For a lot of things, like if we're gonna blink an LED, that works very well. And so if you become familiar with the Arduino, one of the first things you're going to want to do when you move your projects to the Raspberry Pi is learn how to do these simulated analog outputs, which we're going to from now on call PWM, for pulse width modification. To kind of help you through this lesson, I have hooked an oscilloscope up to some of the pins on the Arduino, on the Raspberry Pi, and we can actually watch the signals coming off as we play with the PWM. To kind of catch you up where we are, I have the Raspberry Pi, and I'm using pin 1, 3, 5, 7, 9. Pin 9 as a convenient ground, and I'm using pin 11 as the actual output that I'm looking at. So we're using pin 11 as our GPIO pin and pin 9 as our output. So what I want to do is I want to go in and start playing around with that, and then what you can do is you can play along with me and we'll see how we can start getting this PWM output on these GPIO pins. So you need to open up your terminal window, and the first thing we need to do is we need to go to the command line, or we need to go to the Python shell. And what you got to remember is that as your lowly user Pi, you do not have access to the GPIO pins, and so if you're going to want to manipulate those GPIO pins, you have to be operating as sudo, as the super user. So when you go to the Python shell, you need to do it with the sudo command. So instead of just saying Python, we're going to say sudo Python, and now all of the commands that come in this Python shell are going to be interpreted as coming from sudo, or the super user, as opposed to coming from the lowly Pi user. You can see these three arrows indicate that I am now in the Python shell, and I am ready to send Python commands. We'll come back later and write a Python program, but to start, it just is helpful to start writing commands one line at a time, because I can kind of explain them to you better. If you remember, a lot of this is going to be similar to lesson number 26. If we're going to work with these pins, the first thing we need to do is import. And what do we import? RPI. The case matters, capital R, capital P, little I, and then .GPIO, and then import that as GPIO. So that's importing our RPI library. Boom, that went well. So that's good that we didn't get an error there. Now we need to tell it which numbering scheme we're going to give on the pin. So we do a GPIO .set mode. And this is telling how we want to number the pin. So it's going to be GPIO dot. If we want to do physical pins from lesson 26, what do we do? BOARD. If we wanted to do those outside columns on that chart, that would be .BCM. Okay, so this should set us up with physical pins. Boom, we are set up with physical pins. Okay, now what I need to do is GPIO .setup, and this is going to tell it which pin am I using. I am using pin 11, and I want pin 11 to be a what? GPIO .out. Okay, you know what happened? When I was playing around with this, I didn't do the GPIO .cleanup last time, and so I got a little ugly message, but things should still work. But this is just a reminder to always do a GPIO .cleanup after you finish your programs. And when I was playing around with this before the videos, I didn't clean up my mess. Okay, but things should work from this point. Okay, so I've set pin 11 as an output. So let's just see if I can bring that pin high. What I'm going to do though is, now you can see how I have it hooked up. I have it hooked to this oscilloscope, and you can see that this is a pretty pathetic oscilloscope that I have. If anybody would like to donate a better oscilloscope, I would love to have one. But you can kind of see my zero line is not very horizontal. It's kind of on there crooked, and so you can see this is about a $100 oscilloscope, but it should demonstrate the point. So what you can see right now is that we have 0 volts coming out of that pin 11. Okay, 0 volts coming out that pin 11. All right. Now you remember before, we can come in and from lesson number 26, we can set that pin high. So how would I do that? I would do GPIO. After I get this active again, I would go GPIO, and I would go dot output, and I think that is small output. And then what pin do I want? I want 11. And then what do I want? High, so I'm going to go true. All right. And then watch this signal here as I go true, and boom, you can see that it goes up to 3.3 volts. This is still a DC signal, so not very exciting to look at on the oscilloscope, but let's go back to false. And boom, it goes back down. So you can see that that is sending the voltage up and down. I'm at 1 volt per division, so that's 1, 2, 3, about 3.3 volts within the uncertainty of my lousy oscilloscope. Okay, so that's kind of what we were doing before in lesson number 26, but how do I get this to do some PWM? How do I simulate an analog output with PWM? Okay, well what you got to do is, we've already imported the RPI library. We've already told it that we're doing the physical pins on our pin numbering, and we've already set pin 11 as an output pin. So what do I need now to start getting into the PWM game? Well, I need to create a PWM object, which I will call my_PWM. And what that's going to be is that's going to be equal to GPIO.PWM. And that, I believe, is going to be capital, if I'm not sure, capitalized, okay, if I'm not mistaken. So I'm going to do a GPIO.PWM, and now what pin are we using? 11. And then what do we want for a frequency? We're going to use a frequency of 100 hertz. And that means that it's going to be sort of like a 10 millisecond pulse width, or a 10 millisecond cycle that we're going to be on, because that will be 100 hertz. And so pin 11, 100 hertz. You can set this to other things if you want, but I'm just going to go 100 hertz. All right, and it took it, so that is good. Now what I want to do is I want to do my PWM, and I'm going to start it. Okay. Now, what do I put here? I put the duty cycle. What percentage of this 100 hertz, or 10 milliseconds, do I want to be up, and what percentage do I want to be down? Well, let's do 50%. Okay? And so understand that on my oscilloscope, it's 1 volt per division, and it's 1 millisecond per division. And so if I have 100 hertz, 1 over 100 would be 10 milliseconds, should be the whole cycle, and 50% would be 5 milliseconds. So it should be up for 1, 2, 3, 4, 5, and then it divisions, and then it should be down for 1, 2, 3, 4, 5 divisions. So let's look at this. So I'm going to say start my PWM.start at a 50% duty cycle. And boom, look at that. That is looking beautiful. So I'm up for 5 milliseconds. I am down for 5 milliseconds. A total cycle of 10 milliseconds. That's 100 hertz. And I'm 50% up and 50% down. Well, if this were if we sort of considered this kind of like simulating an analog signal, this would be sort of like 3.3 volts divided by 2, which would be about 1.6, 1.7 volts. This would act like. Okay. So what else can we do? Well, I can do some other things. I can do a my, and then I can do PWM. And what am I going to do? Pay attention to capitalization. Capital C, change. Okay. Capital D-U-T-Y. Capital cycle. So now I can change my duty cycle. Instead of being 50%, what if I go 10%? That should be like 1 division. Boom. Okay. I'm up for 1 millisecond. I'm down for the next 9 milliseconds. What if I change it to a 90% duty cycle? Boom. I'm up 90% of the time. I am down 10% of the time. What if I go and say, I wonder if I can do a 1%. You'd probably barely be able to see that 1% duty cycle. Boom. Just a tenth of a division. I'm up and I'm down the rest of the time. Let's see. Let's go back. Let's do about 25%. That should be good. Okay, so I'm now at a 25% duty cycle. So you can see that with this command, it's sort of like the equivalent to the analog write on the Arduino. On the analog write, you would write sort of I think a number. You would write a number that would sort of be, I think, 0 to 223 or something like that, and that would correspond to like 0 to 5 volts that you were simulating. Here, you do it a little differently. You do it with a my_PWM.change duty cycle, and you can control how long it's up and you can control how long it's down. All right, well, let's see what else I can do. I can also do a my PWM dot, and what I can do is I can change frequency, I believe, and let's say that instead of 100 hertz, let's say I go to 50 hertz, and let's see if that'll work. Okay, look at that. What I did was I changed the frequency to 100 hertz. Let's change it back to 100. Hertz. Okay, we're back to 100 hertz. Let's go to 200. Let's go to 200 hertz. And with that, I'm doubling the frequency, and so I should see 2 of these cycles across the screen instead of 1. Okay, look at that. That's the first one, that's the second one, and so that's 200 hertz. Let's see if we can go, let's go to 1,000 hertz and see what happens. Boom. Okay, so you can see I've got 10 cycles but I still have a duty cycle of 25%. I'm only up 25% of the time. I'm going to go back to 100 Hertz because that's kind of what my oscilloscope screen is set for. So that is pretty slick, isn't it? Okay, so we can look on the oscilloscope and we can see how this is working. But what you usually want to do, what you're really trying to do usually is you're trying to do a circuit. Now I've still got the circuit set up from lesson number 26, and so I'm just going to plug that back in, and then we are going to watch the LED. So I'm going to scoot this on off the screen, and what I'm going to do is I'm going to take these oscilloscope connections off, and I'm going to connect ground here to pin, I believe ground was pin 9. Physical pin 9, so I'm going to go 1, 3, 5, 7, 9. And then this power pin was on physical pin 11. And so we will put that 1, 3, 5, 7, 9, 11. Like that. Okay. And look, we've got a little light on that LED. All right. Now the LED brightness, it's kind of harder for you to see it on the screen here because the LED brightness doesn't show up really good. But let's see if we can control it. Let me go down to, I'm still at 100 Hertz, so that should work. I'm going to go to now my Pwm dot change duty cycle. All right. I'm going to change the duty cycle to 1%. Now understand, if I change the frequency, that's not going to change the brightness of the LED because at any frequency, it's still on for the same amount of time. You're just sort of averaging over a different period. What you got to do to change the brightness is you've got to change the duty cycle. I'm going to go down to 1%, and that should be very, very dim. Okay. Oh yeah, I think you can see that. That's very, very dim. All right, let me see if I can turn the lights off, if that'll help you see it. Yeah, I think that might help you see it a little bit. Okay, well, what if I go to a 0% duty cycle? Okay, that went off. Okay, let's go to 1. All right, and you can kind of see that. Actually, the way your eye perceives things is more on a log scale, and so to kind of show you brightness, I'm going to go more on a log scale. So I think that if I just go to 2, that should be twice as bright, or that on a log scale that should increase it, so you should be able to see the difference between 1 and 2. So let's look. Yeah, I think you can see that's a little brighter too. Let's go 4, a 4% duty cycle. Yeah, that got brighter. Okay, now let's go to 8. Okay, that's brighter. And then let's go to 16. Okay, that's getting way brighter. Let's go to 32% duty cycle. Okay, that's getting much, much brighter. I wonder if you could see this better from the side. Okay, yeah, let me try that. Let me go down to 16 and see. Yeah, I think you can see. You know what? I think you can probably see these differences better if I leave that. This would be the easier way to do it. Bend it over like that. Okay. I think you're going to be able to see the changes a little better. So I'm going to go back to 1. Okay. So there's 1. Okay, very, very dim. You can just barely even see that it's on. I try to get the glare off of it there. You can sort of see that it's on. Now let's go to 2. That came up a little more. Let's go to a duty cycle of 4. Yeah, you can see that. That's showing up. Duty cycle of 8%. Okay. Duty cycle of 16%. Okay, that came on up. Ooh, no. Okay, that you saw change. 32. Okay. Let's go 64. Yeah, you can see that getting brighter. And now let's go all the way to 100%. Okay. Yeah, you can see that that's full brightness. So we are controlling the brightness of the LED using the PWM command. Okay, that is just pretty neat. Let's just try this. What if we say my PWM dot change frequency, and let's go to 1,000 hertz. Okay, I go to 1,000 hertz, and look, there's no difference. Let's go to 10 hertz. Look, there's no difference. Let's go to a duty cycle of 50%. Boom, that made it dimmer. Okay, that made it dimmer. Let's go to a frequency of 50 hertz. I went to 500. Okay, let me go 50 now, and no difference. You see, with the frequency, it doesn't change the brightness because the ratio of time it's on and off stays the same. It's when you change the duty cycle that it changes the brightness. Okay, now what do we do now? The next thing you need to know is, how about if I just want to stop this nonsense? I say my PWM and I do stop and open and close like that. Boom, and it turns it off. What do I always need to do that I didn't do before? I always need to do a GPIO dot clean up, okay, and then like that. Okay, now that's freed everything up. I've cleaned my mess up for the next user. All right, I'm going to Control D out of this shell, and now let's actually write a Python program. So I'm going to go. I'm going to say, let's see, where am I? ls. Okay, I'm going to go change directory to my_Python, and that way I don't have to fool with path names. I'm going to do nano to create a bright.py.py on my Python programs is good housekeeping. Okay, so what do I need to start with? Well, I think that I probably need to import the library capital RP little I dot GPIO, okay, as GPIO. So I import the the RPi library. I need to do a GPIO dot set mode, okay, and I'm going to do a GPIO dot BOARD. That's saying I want the physical pin numbers, not that other goofy pin number. I want the physical pin number. So I do a set mode. Okay, now I'm going to go ahead and set a variable. So where is my red LED? My red LED is 11. So from now on I can just reference it by saying red. Okay, what if I now do a GPIO and I want to do a set up, and that set up I am going to do as which LED? The red. That's like putting 11 in there. And then I want it to be an output. So GPIO dot output. So whether I'm doing this as just a digital write, you know, a true or a false or a 1 or a 0, or if I'm going to try to do PWM, in all cases you set it up as a GPIO output. Okay, so now it is set up as a GPIO output. Yeah, it's set up as output. Now what I can do is I can say my underscore PWM is equal to GPIO dot PWM uppercase, and then let's say which pin, red, and then what frequency do I want? I want 100. Okay, now that is set up. Now I think I am ready to turn the LED on. And remember, I'm going to have to run the program. You won't expect to see anything here. But let's see. I think I'm going to ask the user for input, and then every time I'm going to come back and ask him for input again. So I'm going to say while. I'm going to create a while loop, open, while 1. Let's see, while 1, that should just, 1 is always 1, so I think that should create a loop. I'm a little rusty on Python. How do I indicate the loop? Well, the loop is indicated by tabs. Okay, so what am I going to do? I'm going to say bright is equal to input from the user. What am I going to input from the user? How bright do you want the LED? Okay, I put a space so that it looks nice when you enter it. It doesn't put your answer right up against the question. Close it like that. So I'm asking for input. Now what I want to do is I want to do a my dot at, you know what, I'm going to start it up here. I'm going to start, sorry, before the while loop, I'm going to go ahead and start the PWM pin. So I'm going to say my PWM, and I'm going to start it at 0 duty cycle, so the light won't come on, but at least I've started my PWM dot start. Okay, my PWM dot start at 0. Okay, is not going to turn it on, but at least it sort of starts the PWM process. And so now I'm going to say my PWM. Okay, my PWM dot change duty cycle. All right, I guess I'm going to have to tell them like some range up here. So let's just say we go 1. I'm going to get fancy. I'm going to kind of do this as a log scale. So how many settings would there be? Well, there would be 0, which would be off. Well, let's just start with 1. So I'll say there's 1, 2, 4, 8, 16, 32, 64. Okay, and then that would be the kind of range that we're going to go over. So I'm going to say enter a number between 1 and 7 on brightness. Because the thing is, if you just kind of go linearly, you don't see the changes. You kind of need to try to get a log scale in here so you can see the changes good. Now, we want to change down here. We want to say my underscore PWM dot change duty cycle. And then what we want to do is, gee whiz, I have never done this before. I am doing this on the fly. But I'm going to say to raised to the, where is that? Raised to the right. I have no idea, to be honest with you, whether this is going to work or not. But we can come in and play with it if it doesn't work. So change it. So this should go from sort of like a 2 to a 64 on the duty cycle, and that should be something that we should be able to see pretty well. Okay. Now, when we leave the program, what do we want to do? We're going to do the my PWM dot stop. Okay. And then we're going to do a GPIO dot clean up like that, and just take care of our bookkeeping. How do we save it? Control O, enter, Control X. When we run this, what do we have to remember? That's right, we got to run it as sudo python and then bright.py. So let's see what happens. Ooh, error. Ooh, I know what I did. Sudo or not sudo, just nano bright.py. That should have been out, not output, I do believe. Yeah, that's just out. I hope you guys caught that. Did you catch that when I did that? Control O, Control O, enter, Control X. Okay. Now we are going to sudo python bright again. Ooh, what is it not like this time? PWM. I think I put a comma where I should have put a period. Yeah. So let's sudo nano again. Hopefully you guys caught these problems when I did them. But this GPIO dot, okay, Control O, enter, Control X, run it. Okay. RPI.GPIO line 6. Okay, let's look at that again. Line 6. Let's see, 1, 2, 3, 4, 5, 6. My PWMs. Let's see. That looks good. GPIO setup. Red, comma, GPIO out. That looks good. My PWM is equal to GPIO.pwm, and that is going to be red and 100, and then my PWM.start of 0. I wonder if that is supposed to be a small PWM. Let's try that. Control O, Control X. No, that's uppercase PWM. I am getting perplexed. I hope you guys are seeing this, what I did wrong. Okay, but it wants this to be PWM. So let me look at that. So I do a my PWM is equal to GPIO.pwm, comma, red, which is 11, comma, 100. So that really should work. Control O, enter, Control X. Ah, I misspelled start. Ha! I hope you guys caught that. Okay, Nano Bright. Okay, start. I hope you caught that. You were probably sitting there yelling at the screen at me. Start. S-T-A-R-T. Okay, Control O, enter Control X. All right, now let's run it with sudo python bright. Really? Oh, I see what it was. When I ran it the other times and the program died, it never got to those lines where it cleaned up the code. Okay, so that actually makes sense. Okay, let's go with a 1 and see if we can turn the thing on. Look at that. Look at that. It barely came on. Let's go to a 2. And it looks like okay, I'm going to Control X out of this. Okay, Control C out of it. Okay, that did not like my little attempt at doing a exponential, so we'll just have to do it in our head when we put it on. So let's go back and edit it. Okay, this part, it didn't like this very much, and so let's just not get too fancy here. We'll come back later and we'll get fancy, but let's just do bright. Okay, and then on bright you can enter from 0 to 100. So we'll just go flat out. And what's that? Something that's kind of gotten goofy there. Okay, 0 to 100. Okay, like that. Okay, so now what we will do is Control O and Control O, enter, and Control X. Okay, let's try it now. So we're going to say sudo nano bright. We're going to say sudo python bright.py. Okay, and we got the error message because again we killed the program. It didn't actually go in and gracefully exit out down at the bottom. How bright do you want? Well, I'm going to put a 0, see if that'll work. Okay, 0 is off. I'm going to put a 1. Let's see if it comes on. Yeah, it's sort of barely, you can kind of barely see it there if I sort of shade it. Let's go a 2. Okay, that got brighter. Let's go a 4. That got brighter. Let's go an 8. That got brighter. Let's go a 16. That got brighter. Let's do a 32. Okay, that's brighter. 64. Okay, now let's do a 0. And it goes off. Ha! Boy, we got that working. I am just running. I am kind of, I get stuck on these things and I can't let them go. So I'm going to go Python raise to a power. How do I raise to a power? Mathematical functions. I don't want to. Let's look here. I'm sorry, guys. It just maybe it's a star. Maybe it's like Fortran. Okay, so it's actually pretty easy for me to kind of get confused these different languages and which one works which way. And so let's see if I promise I'll let you go. I won't just keep you on this, but you know, I just darn it, I like to do things fancy. So let's go to star to the bright. Okay, and then in that case, we would still want to go back and have a 1 through 7. Okay, so what we are going to do is we are going to now do a Control O to write out. We're going to do an Enter, and we're going to do a Control X. Okay, and we are going to bravely move ahead here. Sudo Python bright. Okay, we get a warning because we killed the program instead of letting it finish. So let's say if I do a 0, it should be off. So far, so good. Let's see if a 1 brings it on. Okay, I don't believe, yeah, it came on. Let's do a 2. Hey, it got brighter. Let's do a 3. Got brighter. 4, 5, 6, and 7. Okay. Oh, we went to 2 to the, okay, I see it's greater than 100. 2 to the 7th is greater than 100. So what we need to do is we need to edit the program bright.py sudo python sudo nano bright.py. Okay, then we will come down here and we really should just go 1 through 6. Okay. Because we don't want it to go over 100 because that's all we can do. Control O to write out, Enter, Control X. Okay, let's do sudo python bright. Okay, let's do a 0. It's happy. It's oh, okay. Well, 2 to the 0 is still 1, so 0 won't work. It said enter at 1. Okay, so 1 is barely on. 2, it comes up. 3, it comes up higher. 4, it comes up higher. 5 and 6. Which is full bright. Okay, so you see we sort of enter like how you would think of brightness from 1 to 6, but then for you to perceive it the way that I perceive, we need to change that to an exponential scale, and then it sort of smoothly goes up in brightness. Okay, this has been a little bit of a long lesson, but now you see how you can go in and you can simulate analog outputs using pulse width modulation. We kind of did it from the command line, then we kind of came in and did it from the from writing a program. A couple of points. What I've shown you here works really good when your timing isn't critical, when it's not just absolutely critical. So something like how bright an LED is and blinking things and turning things on and off, this works pretty well. If you absolutely have to have completely tight control of timing, like timing critical things, there's a different library that we would want to use, which is called RPIO, and I perhaps in the future will show you I will show you how to use RPIO perhaps in the future. But for right now, for the simple things that you're doing, this will work, and just understand that there is a better library out there if you want to control your timing more perfectly. Okay, so we're kind of getting back to where we were on the Arduino. We can now write digitally to pins. We can simulate an analog output to pins. The Raspberry Pi has a whole lot more pins than the Arduino, so that's an advantage. The other advantage is that we can write more sophisticated programs in Python than what we could in the Arduino environment. So now, here it is on lesson 27. We're finally getting to the point that we can do the things that we could simply do on the Arduino, but now we can do them with the full power of a Linux machine running Python. Okay, Paul McWhorter, TopTechBoy.com. Tune in shortly for the next lesson, where probably we will see how to do inputs from the pins. We've done digital writes. We've done the kind of simulating analog writes with pulse width modulation. The next thing is how do we read from the pin. Paul McWhorter, TopTechBoy.com. If you like this, give us a thumbs up. Think about sharing the lesson or subscribe. Talk to you guys later.